In this video, we're just going to wrap up some of the last calculations from the Monday class. Here we've been given two different vectors, and we're asked to first find a unit vector in the direction of A. So for A is a 4, 0, 3 vector, we can tell that it's clearly longer than 1 unit because it's got one side length that's 4 and another that's 3. It's quite long. However, we can find the exact length using our Pythagorean formula. The length will be 4 squared plus 0 squared plus 3 squared, all square rooted, and that's 16 and 9, that's the square root of 25, which is 5. With that in mind, a unit vector in the direction of A is simply going to be the A vector itself, 4, 0, 3, using the consistent brackets from what we saw in class, and then divided by the length. And that's a perfectly acceptable way to write it. So is 1/5 of 4, 0, 3 vector, or if you want, you can bring that 1/5 inside and talk about the vector 4/5, 0, 3/5. Any one of those forms is completely acceptable. If we found the length of this vector, we would get a length of 1. Moving on, what would A plus B equal? Well, that would simply be adding the coefficients or the components in x, 4 and minus 2, 0 and 1, and 3 and 5. And if we calculate that out, we end up with the vector 2, 1, 8. There we are. If we want to do A minus B, we do all the same operations, except we subtract at each element instead of adding. So 4 minus minus 2, 0 minus 1, and 3 minus 5. That gives us 4 plus 2, which is 6, minus 1, minus 2, as our resulting vector. If we're looking at scalar multiplication, then 3 times the vector B is equal to 3 times the vector -2, 1, 5. And we can essentially distribute that 3 into all the components. So end with minus 6, 3, and 3 times 5 is 15. And last but not least, we can combine scalar multiplication with addition as well. We just do it piece by piece as we would with any other kind of calculation like this. 2a's is going to be twice the A vector, so that would be 8, 0, 6. 5b's, being careful here, would be 5 times -2, -10. 5 times 1 is 5. 5 times 5 is 25. And then we would add those two vectors now that they've been computed. And we'd have 8 minus 10 minus 2. 0 plus 5 is 5. 6 plus 25 is 31. What we used in those previous calculations were essentially the rules here. Sometimes we explicitly stated them, sometimes we just assumed them. Most students don't find these counterintuitive. It basically says that when you're talking about addition or scalar multiplication, vectors behave essentially the same as scalar values do. You can group terms, adding a vector to its negative makes 0, same thing for numbers. You can see all the parallels to each of these constructions when you go back to scalars. So essentially for addition and scalar multiplication, you can trust your intuition when you're doing calculations.